Okay guys, welcome back. We are on day 2. Hopefully you guys are doing well. Thinking about you a lot, hoping the best for you, and let's see how this goes. Okay, so what I did is I already put these in the calculator to make it a little faster. In any case, you have a top function, a bottom function, right? So if you go to the calculator, what I did is I typed those in. Now I typed in all these other ones and I don't want them. That shouldn't even be there because I don't think I need that. Okay, so these I don't want, and I just want to graph those. Okay, so don't forget that when you're dealing with sine and stuff, you have to put a times in there. Okay, so anyway, plot. Here it is. I can see it. Looks pretty good. Okay, I can see that there's 2 areas. Always super good idea to make a sketch of this. So just so that you have, like, you let the reader know, you know, what you're thinking here. And you're thinking, and it also helps you get a visual on what's going on. So this is what we're looking at. We have an intersection, intersection, intersection. Looks like the intersection is 0, 0. Of course, we can confirm that if we want. Intersection, enter, and indeed it is 0, 0. So over here there is an intersection. Wonder what that intersection is. I'm guessing that that's just going to be pi. Let's see. Let me see. Menu. Okay, function, intersection, enter. And oops, I didn't go near it. Whoops. Function, intersection. Okay. And that is 1, 1. I thought so, but you know, you just want to double check. And then over here, this is, since it's symmetrical, it's going to be negative. Now, I know that this is symmetrical over the origin, so it's got point symmetry. And I know that because of the nature of sine curves. Sine curves do that. They are odd functions, so they symmetrical through the origin. And the line y equals x is also considered an odd function, if you can remember that. Okay, so anyway, from Algebra 2 and pre-calc. So ultimately, it says, you know, you got to make sure you write your integral, do it in integral notation, and then a numerical answer. What that means is they just want the integral notation, obviously with all little numbers. So they mean, okay, this is the integral. Hopefully you did this already, from -1 to 0 of, and the top function for this first part is the line, and then the curve is going to be, I'm going to type it in as, since it's, I labeled them over here as F1 for the sine function and F2 for the linear function. So, and the linear function's on top. Linear function's on top for that section. So I'm just going to say F2 of x minus F1 of x dx, and then plus the integral from 0 to 1, and this time they switch. Oops, that's minus. Pencil is a little easier. F1 of x dx. You put them in your calculator, and if you suspect that they're going to be the same for that one part, you're probably right. So I'm gonna go in here. And that would be because it's symmetrical on both sides. But let's show how that works. So you're going to go here, integral -1 to 1. I was kidding, to 0. And then that is alpha F2 of x minus alpha F1 of x, and then that's dx. Enter. And that is 0.1366, and so on. And I'm going to do this side. I terribly don't like to keep typing all those in, so I just copy, paste, and alter, and 1, enter. what a surprise. We knew that was going to happen. But it's good to see how it happens. So in that case, if you know that that's going to be symmetrical, you are permitted to just do from -1 to 0 and put a 2 in front of it because you know it's going to be double. Or from 0 to 1 and put a 2 in front of it because you know it's going to be double. Or just write the whole thing out and it's the same thing, okay? So I'm just going to go here. I'm going to write times 2. And remember that areas between curves are never negative, okay? Negative, not between curves. Negative is when it's y minus the bottom and the curve is below, but that's the integral. So let me see. Where do I put this? I'm like, don't have space. I'm just going to put the answer to the right here. And the answer is 0.273. Good enough. Moving on. Okay, so now moving on to number 2. I already typed this in just to remind you on how to type this in your calculator. You just go into this nifty button right here. Yep, let me get to that. And you will find it in here, right there. And that's how I got that. Okay, so in any case, let's go back to here. So I can clear and let's go back to my apps. I'm under a function because it's not some crazy function here. Here it is. So I'm going to undo these. Right, just do that and then do these plot. Okay, so it's down here. Oh, there it is. Okay, so there's the top function. There's the bottom function. I'm just going to write it right here since it's easier. So my top function seems to be the linear part, and the bottom function seems to be the absolute value function. So this is going to be f of 5 of x minus f of 4 of x, and that's only because I labeled them like that on my calculator. Remember I did that. If you didn't label them like that, yours can be f1 and f2. I just labeled it to make it a little faster for us, okay? In my calculator. So when I went to symbols, you'll see this are the first 2 problems. Here are the ones I'm talking about, 4 and 5. Okay, and now I need the intersection. So I can pretty much see it's 1, 2, 3, 4, 5. But let's just get the exact intersection. Why am I messing around with that intersection? So that x value is -5, I can see. And this one, net function intersection, enter, is 5 dx, and we'll make a little image of this. Oops, that's no good. Something like that, and then the other one's like that, and we're good to go. Okay, plug that in the calculator, plot, and do I have this answer? I thought I did, but I guess I don't. So you just type that right in. Okay, plot -5, -5, and it's alpha f 5 of x minus alpha f 6, I believe. 6. Oops, I was kidding. 4 of x. Okay, dx. Okay, enter. 24. Okay, that's a miraculous little 2 there. Okay, so now, lastly, to this page, this one's no calculator. Okay, so I gotta put away my calculator and know that this is a parabola and a line. So that's okay. I can make a sketch of this. I know what a parabola looks like. It looks like this. And if you don't, you will hopefully now know. And it goes to the origin. What was I drawing? It goes to the origin. It looks like this, like this. This is just a line with a slope of 4. It's pretty steep if you remember from slope fields, but because I don't have any room, mine's not going to be that steep. So just bear with me. Okay, so that's 4x. Okay, so it's from 0 to, now you can guess, or you could just be like, well, I'll just set those two equal. X squared equals 4x. So x squared minus 4x equals 0. So GCF Oh, yay. X equals 0. X equals 4. There's my 4. Good. So now, let's let the fun continue. Oh, you can't even see this. I'm thinking you're seeing this. Okay. Yeah, all I did was move that guy over, factor, all that business. Okay, so now, let's keep on going. Now let's do the integral from 0 to 4, because those are the x values. The top function's my linear, so that's 4x. My bottom function, that says 4x, okay. My bottom function is my x squared. This is dx. And since it's no calculator and they didn't say, hey, just write the integral and that's it, they want you to actually do the whole thing. So yes, do the whole thing because you need the practice. What? Of course you do. Minus x to the third over 3, 2, 4. And, you know, check that and then put the 4 in. Okay, so I am going to continue this fun over here. So it would be 4, and then I type in 4. Well, I can simplify that. This is the same as 2x squared minus x cubed over 3, 0 to 4. So if I put 4 in here, that's 2 times 4 squared is 16 minus 64 over 3 minus 0 minus 0. So this is 32 minus 64 over 3. So then that's 96 minus 64 over 3. And 6 minus, oh, sorry, my hair. 6 minus 2, 3, oops, come back, over 3. It's not a negative. That would make no sense if it was negative. And I'm glad Diana said yesterday, like, she got some negative answers and knew that something was wrong. She's right. That is correct. It should not be negative. All right, moving on. Oh, yep, sorry about that. Okay. All right, so now, ooh, look how exciting. More no calculator. Yay. Okay, so we have to determine the area enclosed by this and this. And you're looking at these two and you're like, what? So you can go, I can get y alone. And you can, if you were to try and get y alone, you would have to do plus minus with a radical. If you see what I'm talking about, I'd be like, oh, minus the x. And then I would have y squared equals 3 minus x, and then square root both sides, and it's a plus and a minus. And it can get pretty interesting. You can do that, but I'm going to recommend, since it's easier to get x alone, to just stick with that. Get x alone. So okay, so x, this is going to break again. X equals negative y squared, I knew that, plus 3. Okay, so that's that one. And this one over here is x equals negative y squared over 4, right? You got that. So you have these two functions. You're like, how am I supposed to plot that? There's more than one way to plot this. Of course, you could get y by itself and plot it that way. But like, think of this way, okay? Think in your head when I look at this, and I'm gonna erase it soon, but just so that you can get an idea of what this is. Think that this is y equals negative x squared plus 3. Just switch them over for a second, just to get a visual on that. So y equals negative x squared. It's the same thing, I just switched x and y. If you were to graph that, that would be a frowny face shifted up 3, right? And then if you were to graph y equals negative x squared over 4, that'd be a frowny face, but going through the origin. So it would just be like that, right? And this would be the area. So you would know immediately that this would be your top function, right? So since we know we're doing this from right minus left, this would be my right function. This would be my right function. And this would be my one on the bottom, or my left, because we go right to left. Okay, if you still write top and bottom, you're really not wrong. We get the idea. It's all about the integral setup, and that's it. okay? So because I was able to imagine this, and this I know is not the actual, this is graphed basically saying that this is y and this is x, right? I know it's normally the other way around, but the way we did this, we switched x and y, so technically wouldn't this kind of be like called, you know, y and x based from here? But anyway, so this is how that's how I figure that out, okay? So now that I know that, I really don't need this here because I used that trick just to understand how it was. And I don't know what I did. Oh, here, my sushi eraser. It's like cool, right? It's a little sushi, but it's an eraser. Yeah, I want to get this out of the way. Okay. So now, since I know which one's on top, go away. Okay. It's going to be this one. So it's going to be negative y squared plus 3 minus negative y squared over 4. And this is dy, and now I need these y values, okay? So in order to get those y values, I need the intersection. So once you have x equals and x equals, you can get your intersection, okay? So your intersection would be, let's see if you can see that, intersection. So I'm going to take negative y squared plus 3 equals negative y squared over 4. Right, I don't really like any fractions, so I'm just going to multiply everything by 4. I'll just do it this way, that's fine. Oops, that's to multiply by 4. I just multiply every single thing by 4. Okay, that way that cancels out. Now I can move this over to one side or the other. I guess I'll just go that way so that it's a positive y squared. So this will be 0 equal to 3y squared minus 12. I can take out, I guess I could have really just left the 12 actually. I'm going to do that. Sorry. So I'm just going to make it 12 equal to 3y squared, because I mean, it's not like I have y and y squared. If I have y and y squared, factoring has to happen. But if I just have y, or if I just have y squared, well, I can isolate one of those and then just, you know, solve that way. So this is 12 divided by 3 is 4 equal to y squared. So y is equal to plus minus 2. Okay, so that takes me back to these numbers over here. There we go. That's what I have to find. All right, so I'm not done. I need to work this out. So I'm gonna bring it over here where there's more room. So this is, I'm gonna clean this up. Negative 2 to 2. So this is negative y squared plus 3 plus y squared over 4, right, dy. And if I get the antiderivative of that, I guess I could combine like terms here, but I'm not going to bother. Negative y to the third over 3 plus 3y plus y to the third over 3, and there's a 4 there, so it'll be 4 times 3. I have to keep checking to see if you can see, because it's like I have to work around this camera here. Okay, so now plugging in, so that's negative, if I plug in the 2, that's negative 8 over 3, plus plug in the 2, I get 6, plus plug in the 2, I get 8 over 12, minus. Now, if I plug in negative 2, I get negative 8 over 3, plus plug that in, it's negative 6, plus plug that in, it's negative 8 over 12. Great. Over 12, there we go. Okay, you can see it. Okay, so now we gotta work this all out. So since they have the same denominators here and here, you know, a lot of this is very much the same. So I can look at this and be like, okay, this is negative 8 over 3 plus, well, I'll just change all the signs. I'm going to leave it 8 over 12, even though I can simplify it. If I make this a plus and then distribute the negative, that becomes negative 8 over 3. If I distribute this negative to here, that will make this positive 6. If I distribute this negative into here, that'll make it positive 8 over 12. Okay, combining with the terms that go together, that's negative 16 over 3. This is plus 12, and then this is 16 over 12. And if I divide, simplify that, divide them both by 4, that would be 4 over 3. Okay, so this ends up being 12 minus 12 over 3. Did I do that right? Negative 16 plus 4, yeah. Which is the same as 12 minus 12 over 3 is 4. So this is the same as 8. Yay. We can check with our calculator, but that's that. No calculator. We survived. You can do that too in the safety of your own home. See that? Now, let's move on. You have no calculator. Determine the area of the enclosed region by these two curves. Again, no calculator. Again, I'd have to do like the plus minus thing, which I try to avoid if possible. If I can get x by itself, over here I can get x by itself too. Or if I want, like somebody might be like, you know what, Miss Grassy, why can't you just leave it and just do the radical and do the top and the bottom? I mean, we can do that too. Let's get a picture of it doing that. Like if this is y, this would be y is equal to plus minus the square root of 2x plus 6. Like this graph would look something like, this is a radical function shifted left, right? Because this is like 2x minus x plus 3. So that's a shift to the left 3, but then there's a stretch. So you don't have to have it perfectly, but you just need to know it looks something like this. And this one is, and that's the top part. This is the top part of the square root, and this is the bottom part. So this is like y equals square root 2x plus 6. This is y equals square root negative square root 2x plus 6. That's what's happening. Now if I go and get the other guy is right here is at y-intercept is -1. It just goes up. So it does something like this. Okay, and that's the linear. So yeah, you can see, and if you want to break this up, this is a pain in the neck. You have, I was trying to explain it to you in the session when we met up before. This is breaking up. If I see top bottom, this top and this bottom, if I remember like little handcuffs holding them together, the top bottom is between the top radical, bottom radical, top radical, bottom radical, top radical, and then over here it splits up, and then they switch being the top radical and then the line. Okay, so I'm thinking this might be a good time to do it both ways again, okay? Just because I think it's good to know both ways. And then, of course, you're allowed to decide. And they really test that you understand both ways. So that's why I do it, okay? So, yeah, but the line, I don't know what the heck this is. But the line where it switches over is right here, where that, where the top and bottom are different now. See? This one, and then it's this one, and this one. They go together, okay? So that to complete the area between the curves. Okay, so we'll do this. I'll do the setup for it, but I think algebraically I'm going to do the other way, okay? So the setup for it is going to be doing it in terms of delta x method, right? This integral would be, the top function would be radical 2x plus 6. The bottom function, so it'll be minus negative radical 2x plus 6. So they kind of do like a double version here. And this is from, I have to figure that out. Then I have to figure out where this is all happening. So I have to get these numbers. All right, that's dx plus, I'm going to hold off on those numbers in a second, okay? So, and then this next part's going to be whatever that number is up to wherever that number is. Of course, I have to get all these values, but of course, the top function is still 2x plus 6, and the bottom function is now just x minus 1. I better put that in parentheses, okay? All right, so now I got to get these numbers. And the way you get these numbers is like the two things, the top bottom thing that you are working out, you have to find where this root of that is, where they intersect pretty much, right? So if you just kind of set these two equal to each other, you're really just finding the root of that. So where is that? So you can say, let me see if I can write it over here. Okay. Intersections. Okay. So this root here would be where square root of 2x plus 6 equals 0. So that's where x is equal to negative 3, right? You can see, plug it in, that's x. So that's negative 3. So this is negative 3, right? That's negative 3. I put that there. All the way to, let me just label it here. All the way to, oh, so when do these two intersect? When does this line intersect with this graph, with this bottom graph right here? So I'll find that intersection right here. I'll do that right here because I feel like I have a little space there. So I'm going to say where negative square root 2x plus 6 is equal to my line, which is x minus 1. Square both sides. And by the way, if you come up with the number in your head without doing the algebra, that's okay too. Sometimes it's like 1, 2, and you like come up with it. Like if you put in 2, let's say 4. No, it's not going to be that. But like sometimes you can come up with it. That's fine too. But I don't know. Let's square both sides. That will make it 2x plus 6 equals x squared minus 2x plus 1, because I'd have to have FOILed that, right? So x minus 1 times x minus 1. And then 0 is equal to x squared minus 4x minus 5. So x minus 5, x plus 1. So is equal to 0. So x is equal to 5, x is equal to negative 1. So by the looks of this, this must be negative 1 here, and that must be 5. Okay, so this is to negative 1, and then this is from negative 1 to 5. And then we're going to add them, and that's how you would get that. And you can do all that, and you can, so this is from negative 3 to negative 1, and then this is from negative 1 to 5, and I add them, and I would get the area. Now I could do this algebraic work, or if I did this in terms of delta y instead of all this, I'm going to do that here. Okay, so delta x method is this one. This is delta y method. Okay, so in order to do delta y, I have to write both my equations in terms of x. So I have y equals x minus 1. So I have to get x alone. So x equals y plus 1. So there's 1. And then I have y squared equals 2x plus 6. And I got to get x alone. So, so 2x equals y squared minus 6. So x equals, thank you, x equals y squared minus 6 over 2. So there's my other guy, all right? So those are my two functions, and I got to set them. I gotta set them equal to find their intersections in terms of y. So I go y plus 1 equals y squared minus 6 over 2. Okay, all right. Okay, I can cross multiply. So 2y plus 2 equals y squared minus 6. So 0 is equal to y squared minus 2y minus 8. So 0 is equal to y minus 4, y plus, stop sliding down. So y plus 2. So y is equal to 4, y is equal to -2. Okay, so now I know those are going to be, now when I look at my picture, and I don't even have to have a picture to know that this is just going to be these y values that I'm going to need. So you pretty much have it at this point. So this is the integral from -2 to 4 of, and the top function is the line. So that's y plus 1. The bottom function is y squared minus 6 over 2 dy. And now you have to get those integrals. So I'd have to break that up. So I'm going to make that minus y squared over 2. And then y squared over 2 minus 3. Okay, so now this is equal. I ran out of room. I'll figure it out. Okay, so now I got to get the antiderivative. So that antiderivative is going to be, well, actually, before I get that antiderivative, I'm going to simplify this. Okay, so this is going to simplify to -2 to 4, and this is y plus 1, and then this is minus y squared over 2, and since I'm doing -3, that would be plus 3. So this is -2 to 4 of y plus y squared over 2 plus 4. So when I get my antiderivative, that's y squared over 2 plus y to the 3 over 6 plus 4y, -2 to 4. There we go. Okay. And then plug in the 4. So that's 16 over 2 plus 64 over 6 plus 16 minus, and you plug in the 2. -2 rather. So that's 4 over 2, which is 2, plus I plug in, that would be -8 over 6. So that's -4 over 3. And plug that in, and that's -8. Okay, so let me see. Can I simplify? Well, this is just 8 plus, and 64, that's what, 32 over 3 plus 16 minus, this is -6 minus 4 over 3. Technically speaking, just so you know, as soon as you plug this in, this is actually correct. As soon as you plug them in. Here, no, but yes, once you plug it in, and you would be done with that on the AP. But for now, I figure it's right to like finish off the whole thing. You might as well. So 8 minus -6, so that's 14. And then 32 over 3 plus 4 over 3, that's 36 over 3. And then 16. Oh, I could have combined that. I didn't even notice that. So then that's 10, 20, 30 minus, and then that's, so then that's 20, so that's 18, and the answer is 18. Ugh. All right, so anyway, there's that. But like I said, you are actually done at this point. You could have just plugged in, move on to the next. Just a good habit. You know, those multiple choice questions aren't normally done that way. All right. It's 34 minutes. This is a few more of these practice problems. These I'm going to put on Canvas as the just like already worked out. You should be able to realize top, bottom, top, bottom, top, bottom, and be able to flip that out. That you should be able to do on your own. I don't know if I have that one as without a calculator. I think that would be with calculator. This would be a with calculator situation. So you just got to, so which isn't so bad because then you can just set up the integral. Both of these are with calculators. So, I mean, I will set them up, but then I'll put the calculations in the back, if that's okay. Okay. So the top part's the line. What is the equation? Oh, here it is. It's like so hidden. So negative x, oh, sorry. You can't see that, can you? So negative x plus 2 is your top function for here. That's the linear. Oh, gosh. Darn it, I need to make this further away. Sorry. Okay, that's a little better. Okay. All right, so yeah, so this is my top function and the curvy part's the bottom. So the linear is my top function. So it's that minus the bottom function is 4 minus x squared, right? And then that's that dx, and that is from -2 to -1 plus, and then from -1 to 2, this top function is the curvy guy, so that is 4 minus x squared minus then the linear guy, negative x plus 2 dx, plus then we go from 2 to 3 of the top guy is the line negative x plus 2 minus 4 minus x squared dx. And then I would expect you, I suggest you compute each one. Yes, you can type the whole thing in. I just find like it always has like a problem. So it's just better to do each one. And that way, if you get some sort of wacky number that's like humongous and way more than it should be, you know, you did something, you know, something that needs to be looked at. So then you just type them all in, add them all together and get the answer. I'll put all that in the, in the drive, I mean, in our Canvas. That way you can see it, you know, calculated and stuff. But I'm not going to sit here and waste your time with watching me press all the little buttons. All right. Here, the setup again, it's a matter of top minus bottom. I think this time I can move this Harry Potter book and I can go here. Okay. So the top function is, in this case, this line, which is just 2x, and then the curve, which is x squared minus 4x. So all this day 2 was literally an extension of day 1, just like practice it. Day 1 had everything in it. Day 2 was like, okay, it was a lot. What can you do? It's actually ended up being over 3 days. So if you're starting to get this, kudos to you. It takes a while. So this is from 0 to, you know what? This was purposely done giving you a coordinate because people get confused as to what you put in. Remember, this is dx. dx. These are x values. In here needs to be the x value to the x value. Do not put in the y. They purposely give you coordinates to see that you know which number to put in. This is my x value that I put in. This is my x value. So this is from 0 to 6. It's those x values, and I told you I'd compute that. I will. Probably wasn't too hard. You could have done that by hand, but it doesn't say no calculator. So wait a minute. All right, sorry about that. I just realized I missed a question. This goes here. Oops, so sorry. I was a little too eager, getting a little too crazy. So let me just rewrite that here. Minus x squared minus 4x dx. And you would put that in here, right? And then I'll work that out. And then this one, so sorry. I like just totally did not acknowledge there was a question here. I just go right to the picture. See, I told you I don't like reading. I just want to get right to the math. To the fun stuff. No groaning. Okay. All right. That one. Ooh, no picture. We have to make our own picture. Well, that's exciting, isn't it? So you're just gonna a sine curve and a cosine curve. And it's bounded by these two things here. Okay, you can see it now. Okay, so sine curve I know starts with O, max O, min O. So it does something like that. Am I cutting it off again? okay? And then the cosine curve starts at the top here, and it just does this. And where this is maxing, this is, I don't know why I do that so high, right? So, and then it keeps going. So they say from 0 to 9, at x equals pi over 2, that's like 90 degrees. So this is O, max O. So here's 90 degrees. This is pi over 4, if you remember. And then this would be like pi down here. And then it go up something like that. But, and over here, this here. So this is not pi over 2. I said pi over 2. I wrote pi over 4. What nonsense is that? Pi over 2. Over here is pi. That's why I thought about it, because I know where they intersect, where cosine and sine meet up, where they have their good time hanging out together. That's at pi over 4. Okay, so so they want you to find the area that is specifically enclosed by the sine curve, the cosine curve. X equals 0, I did not mark that, that's this part. And x equals pi over 2, that's here. So they want this and this. Kind of looks like a cute little bow tie. That's what they want. They want you to find that area. See that? So you have like a top and a bottom, and then they switch out. Top, bottom, switches out again. So you're going to write that integral and get that answer, and that's all that is. So that one looks something like, you try it on your own. You should pause and try it, and then see if you come up with the same thing, okay? That is how these videos work very well, that you pause and do it, and then see if I get the same thing. And if you get it wrong, you just erase it and change it, and nothing bad happens. You know, it's safe to make mistakes, okay? Pi over 4. And this is from 0 to pi over 4. The top function is my cosine x minus sine x dx plus, oh, well, I'll write it next to it this time. And then I go from pi over 4 to pi over 2, and that's sine x minus cosine x dx. Now you can just type that beautiful thing right in, and you got yourself an answer. Of course, you can do it algebraically, you know, for fun, because you have so much free time with nothing else to do. And I don't believe that, actually. I think you guys are getting a lot of work to do. So, and if it is a lot of work, I do apologize for everyone, but it will get better. I do believe it's a lot of work for me. I have been working nonstop, like until 11 o'clock. So it's nonstop. And I think it will get better once we get used to all of this. Again, I said I would post these answers worked out. Right now, I'm just doing the setup. I just don't think you want to watch me set up, like type a bunch of buttons in the calculator. So we'll just move on. And then this last one over here is, ooh, look at the fun. It says no calculator. That means no calculator. So that's okay, because it gives you a picture. And you might be like, oh, I can do top bottom because look at these little lines. Yeah, don't fall for that, okay? Because if you try to do top bottom, look at this, says x equals. You'd have to make it y equals, which you can. But why? Like, we can go this way. It's so much better. Like, the top bottom is the same the whole time. It doesn't, like, do this switch up. Like, over here, top, and then the x-axis. And then over here, it switches over. Like, this line's the top, and then this. It's not the same. They're not like, if you did the handcuffs, they'd switch over to something else. So, you're going to do right to left. So, this is going to be radical y is my right side. And my bottom is going to be y squared minus 1 dy. And these have to be dy, y values. That's right, y values, everybody. Y values, okay? So that means below to top. That's y equals 0 to y equals 1, ladies and gentlemen. So that's what goes in there. Good stuff. So now all you got to do is, since it's no calculator, is you get to have all the fun of getting the antiderivative and plugging in and solving. Good news, don't freak out. Good news, there's a little 0 there. 0 and 1s are awesome because calculations are faster that way. So let's do this. This is, that's like y to the 1/2, right? So plus, so when you get the antiderivative, that's going to be y to the, 3 over 2, 2/3 minus, and then I'm going to distribute that negative. So then that's y to the third over 3. And then I know it would normally be minus, but because of the negative in front of the parentheses, if you can see there, that would be plus 1, so that would just be y. Evaluate this from 0 to 1, and this is 2/3 1 to the 3/2 minus 1 to the third over 3 plus 1 minus, 0 minus 0 plus 0. Fun stuff. Now this, I'm going to bring this over here, and that is 2/3 minus 1/3 and plus 1. So that's just 1/3 plus 1. So this is just 1 and 1/3, or I don't know, you can say 4/3, whatever floats your boat, people. And there you have that. Okay, this one was saying it's a challenge, but it was more than just a challenge. It was a mistake. So this is where you cross out and be like, oh, thank goodness we don't have to do that. Go get something, go do something fun, get a snack, have a good day, take care of yourself, be well, and try and stay happy doing all your fun-loving math. Take care. Bye.